Audio Jungle.
Hi, my name is Alisha Roberts. And I'm Jourdan, and the purpose of our experiment today is to determine whether or not different objects fall at different speeds. Our hypothesis is different objects will fall at different speeds. So basically, we're recreating Galileo's experiment just more carefully and in a smaller area.
Audio Jungle.
The materials used to conduct our experiment were 2 metal rods along with a clamp. We had 3 objects, a softball, a baseball, and a ball bearing. We had our spark timer with our spark tape. We had a tape measure, a calculator, and an electronic balance. We also had a camera and tripod, a pen and pencil, and a foam pad and bucket for our objects to fall into.
Audio Jungle.
Safety tips. Our number 1 is avoid touching the metal parts on the spark timer. Trust me, you will get shocked. And the second one is to be careful on any high objects that you're standing on, such as a countertop or a chair.
Audio Jungle.
A clamp was placed on an electronic balance and its mass was zeroed out. Each object was placed on top of the clamp so that it remained stable while it was weighed.
Each object's height was measured. In order to get an accurate measurement, each object needed to be measured from the bottom of the ball to the foam pad. Measurements were recorded in meters.
Each object was dropped multiple times from the height measured. The timing technique used was by using the spark timer. To use the spark timer, each metal clamp needs to be placed on each side of the spark timer electrode. Make sure the spark timer is not plugged in during this time. You can choose different voltages by turning the dial. Ours is at 60 Hz. This will give us a dot on the spark tape once every 60th of a second, so 60 dots is equal to 1 second. Push the red button when ready to start and drop the object. Now, to calculate the time, you count how many dots are on the spark tape. Each dot looks like this. They're circled on the spark tape. To make sure our data is accurate, we made sure the spark tape was measured to the same height the objects were dropped.
Audio Jungle.
The formulas that we used was 1, distance equals half gt squared, where g is the gravity, which is 9.8 meters per second squared. The second is time equals the square root of d over half times g, which is equal to the square root of d over 4.9. The third is percent error is equal to observed time minus theoretical time divided by theoretical time times 100.
Audio Jungle.
our data that we recorded was then put into a chart just like we have here up on the board. We have our three objects, a softball, a baseball, and a ball bearing. We recorded the mass of each object, and then we also have the measured height of each object showing here.
Okay, we'll go ahead and start with the softball. The softball, we recorded 3 different trials. The first trial, we got 43 out of 60 dots on the spark tape, which is equal to 0.72 seconds. On the second trial, we got 42 dots out of 60, which is equal to 0.70 seconds. And the third trial, we got 45 out of 60 dots, which is equal to 0.75 seconds. Now, to calculate the theoretical time, we use the equation T equals the square root of D over 4.9, which is equal to 0.684 seconds. Now, going to the observed height, which is the computed distance, we use the equation D is equal to half gt squared, which is equal to half times 9.8 meters per second squared, which is gravity, times 0.72 seconds squared, which is the time used, which was the observed time used for the softball, which is equal to 2.540 meters. We did the exact same thing for the second and third trial as well, and we got a distance of 2.401 meters for the second trial and 2.756 meters for the third trial. The next object is the baseball. The baseball, we got 43 out of 60 dots, which is equal to 0.72 seconds. And then we plug that into the time formula, which gave us a theoretical time of 0.688 seconds. And then we calculated the computed distance, which is the observed height, and we get 2.540 meters. The third object was the ball bearing. The ball bearing, we calculated 46 out of 60 dots, which is equal to 0.77 seconds. We plugged that time into the time formula, which is equal to 0.693 seconds. Then we did the exact same thing we did for the softball and the baseball, and we plugged that into the distance formula, and we got a distance of 2.905 meters. Now, when we calculated the percent error for each trial of the softball, the trial for the baseball and the trial for the ball bearing, the first trial for the softball, we got a percent error of 5.26%. We got a percent error for the second one, which was 2.34%. Our percent error for the third trial of the softball was 9.65%. The percent error for the baseball was 4.65%, and the percent error for the ball bearing was 11.11%. And to find the percent error, we did the observed time minus the theoretical time over the theoretical time times 100.
Audio Jungle. Audio Jungle.
The conclusions to our experiment are: the shape or mass of the objects do not affect how fast the objects fall. There seems to be a consistent difference in the observed time and the actual time. The observed time is always larger. This small inaccuracy may be caused from some residual friction within the experimental apparatus.
Because of the residual friction in the experimental apparatus, this limits us to a 2.0% error, which is the smallest percent error we can hope for. Another limitation was the timing, because we can only calculate to 1/60th of a second. And our height was also a limitation because the objects were dropped from a low height, which will only give us approximately 45 dots to measure with. So, to the answer to the question, does different objects fall at different speeds? No, our resulting calculations disprove our hypothesis.